Very good afternoon to all of you, respected chairpersons, professors. It's okay? Oh, okay. My friends, colleagues, I am Kasturi Bhattacharyya from Indian Institute of Technology, Kharagpur. I'll be presenting the topic petrology of the Proterozoic kolhan group of rocks from Chaibasa Normandy Basin in Jharkhand, tectonic implications. Now, the major objectives of my work was to do the petrology of the sedimentary rocks in and around the Chaibasa Normandy Basin in Jharkhand, then to do the sandstone shale geochemistry, and from the petrology and geochemistry to come up with the tectonic framework of the basin. So I'll give you the tectonic implications of the kolhan group of rocks in Chaibasa Normandy Basin. Now, to give you an overview of the basin, the 2.2-2.1 gigayon pear-shaped kolhan basin is a time-transgressive shale-dominated supracrustal succession set in a passive continental rift setting and caused due to the fragmentation of the Rodinia supercontinent. The succession is a sequence of subarcos quartz adonite with lenses of conglomerate overlain by extensive thick shale limestone package and show a non-cyclicity in the sedimentation history. The kolhans were basically deposited in an intracratonic basin that had a westward slope and were subsequently deformed into a synclinal structure. The depositories of this basin unconfirmedly overlie the older granitoids of different types and ages and members of the iron ore group. Now, this is the cross-section of the basin, and as you can see, I've already said that, how does this work? Okay. There is a Singhbum granite to the one side and iron ore group on the other side. This is the synclinal structure of the basin, and this is the other cross-section. Now, this is the paleogeography of the time, and this is the red portion is the basin. Which
even before the deposition?
No,
it is only basic deposition?
No, basin deposition.
It is only depression.
Yes. Now, this is the tectonic map of India where you can see the different tectonic units of India, and we are working on the Singhbum craton that I've marked with the red color, and this Singhbum craton is zoomed here where we have pointed with blue the Chaibasa Normandy Basin. This is once again the cross section, and this is the map view where you can see that the northern boundary is bounded by the iron ore group and it is separated from the basin by a fault, and this boundary is an unconformity between the shale, the kolhan group of rocks, and the Singhbum granite. Now, next, we look at a Google satellite imagery map where you see dolerite dikes intruding the basin. This is another satellite imagery map where we delineate the basin with a pink color. Next, we come to the stratigraphy of the basin, which begins with the Singhbum granite at the base, and it is overlain by the unconformity. Now, above the unconformity, you have the kolhan conglomerates, and then you have the kolhan sandstones, and above all, you have a huge thickness of kolhan shale with intermittent presence of limestone. And above all, the younger ones are the newer dolerite dikes which have intruded the basin. Next, we see that the Singhbum craton has a limited paleoproterozoic supracrustal record, which basically can be divided into three-part history. The first part is a long period of high freeboard and paleosol formation on the granitoids, that is the Singhbum granite. Next phase is the subsequent rift related mafic, ultramafic volcanism and subordinate sedimentation, and the last one, it is an overlap locally with mafic soil formation and a major regression at 2 gigayon. So What is the global importance of the kolhan group of rocks? If we see the petrology, geochemistry and paleogeography, it can be compared with the Pretoria group of the Kabwal Craton in Africa. So basically the Singhbum Craton and Kabwal Craton and these two group of rocks, the kolhan group of rocks and the Pretoria group of rocks, these are basically the sundered fragments of the same Archean craton. That gives the global importance of the kolhan group of rocks. Next, we look at the finding up succession of the basin, where in the base you have the conglomerates, a thin presence of the sandstones, which represents the braided fluvial system, and above it a 200-meter huge thickness of shale with intermittent presence of limestone. So basically what we observe in the basin is a strong asymmetry in the vertical basin architecture and linearity in the outcrop pattern of the preserved sedimentary sequence, and these are presumed to have developed in an elongated trough during the initial basinal rifting stage, while the later stage is marked by progressive overlaps and coalesce of facies buildup. Now this finding upward sequence, the lateral facies variation, which is this one, in the kolhan implies basically the superimposition of a retrograding fan delta complex on an earlier prograding alluvial fan sand complex in the lower kolhans. It is exposed in the Keonjhar basin. So next we show the fault marking the basin boundary, and this is the red line marking the fault. The regional stratigraphy and the gradational facies relationship between clastic carbonate members compels one to interpret that the entire kolhan sequence is non-marine. The pattern of sedimentation.
The fan delta you are showing, the fan delta you are showing, the fan delta, is there any remnant fan delta in those areas? Remnant? Or only from the sedimentological
I
side?
will show some pictures which will give you the answer. So
I think Dr. Ramsamy, it's better to give her a chance to complete it.
yeah,
and then ask
there are
what you
sedimentary
need.
structures, and what you are, I will show in the subsequent
Okay,
slides.
continue on
Uh,
presentation and
the-
discussion after.
The pattern of sedimentation associated with the basin floor reflects a sequence of emergence, submergence and reemergence of the land surface related to the development of an extensive ephemeral lake. Now the early emergence of the kolhan land surface led to the development of the erosional topography and also involved lowering of the local base level of for at least a few meters. Now this suggests a tectonic uplift of the area. Now next we show the fault scarp exposed at the western margin. The foreground is the kolhan basin and the high hills is the iron ore group. And here, this is the composite lithologue, which is beginning with the outcrop of the kolhan conglomerate deposited over the eroded granitoid mass, followed by the different sandstone facies, the sandstone massive facies, ripple sandstone facies, amalgamated sheet sandstone, ripple sandstone facies, bar stratification facies, then there is rhythmic alteration of sandstone shell facies, then followed by asymmetric mud ripples in the flying clastics approaching the lacustrine environment, and normal faults bounding the western margin of the basin, and then you have the pro-delta shales, and once again the lacustrine facies. So if you look at the entire sequence, beginning with an unconformity followed by a sandstone facies and then shale containing lacustrine facies, so the environment basically changed from braided fluvial to lacustrine environment. Now if we go into the detailed pictures, the first one is the outcrop of the kolhan conglomerate deposited of the eroded granitoid mass. The red line marks the boundary between the Singhbum granite and the conglomerates, which is the beginning of the kolhan group. Next, you have the sandstone species, and this is a ripple sandstone species, which is followed by the amalgamated seed sandstone ripple sandstone species, overlain by a bar stratification channel species. So, sir, these are the channel species, the bar stratification species. So, from the different associations, we say that it is braided fluvial. Next, you have this rhythmic alteration of sandstone shell species, from which we imply that there was a steady growth of the basin with slow subsidence. And then again we have a bar stratification species. This is the normal fault, and above all we have the asymmetric mud ripples in finer clastics, which indicates the approaching lacustrine environment. Now, this is a very good section which will answer sir's question. This is an Aeolian dune overlain by the preserved fluvial channel, and you have the fluvial sandstones here, and then you have the overlain lacustrine shales. So in this sequence you can clearly see that the fluvial environment has changed into a lacustrine environment. Now, next is the pro-delta sandstone shell facies, and next we go into the weathering intensity, where we see that the feldspars are concentrated in the braided fluvial deltas, and the finer clastics are shales that are carried farther into the basin. So there is transport segregation. Now, if we show the synoptic paleocurrent view, we can see that the paleocurrent data suggests that the position of the fall blocks strongly influence the deposition of the fan bodies. Subsidence pulses probably controlled successive major progradational phases, leading to the development of the superposed coarser and finer units. Now, the clockwise block tilting associated with subsidence during Rabin evolution is indicated by the spatial relationships between the fan delta progradational phases, where a new fan delta segment developed basinward at the toe of an older fan segment. This also suggests asymmetric Rabin geometry for the basin at this time. Therefore, from all these we can say that the sedimentation of the lacustrine fan delta lithophyses association of the kolhans took place in a northeast-southwest elongated continental rift basin, which will come up in this figure, compartmentalized by the north, west, southeast and east-west trending normal faults. The basin fill architecture was probably determined by the episodic subsidence, clockwise block tilting, and asymmetric Rabin evolution, as well as by the inherited characteristics of the source area. We also find sedimentary structures like the convolute laminations in the area, from which we can say that there was recurrent seismic or tectonic triggering of the basin, as also indicated by soft sediment deformation structures in different stratigraphic units. The fluvial system was marked by a remarkably persistent northern paleocurrent and a northerly paleoslope throughout the kolhan sedimentation phase. The repeated fall-controlled uplift of the source followed by subsidence generated multiple fining upwards cycles and a retrograding fan delta. The marked variations in thickness of delta succession and stacking pattern in different measured profiles reflect the overriding tectonic controls on fan delta evolution. The accumulated fault displacement in active sectors created higher accommodation and thicker delta sequences. There was intermittent uplift of fall blocks, exposed the fresh bedrock to mechanical weathering, generated large amount of detritus, and resulted in forced closure of the landlocked basin, repeatedly disrupting the fining upward pattern. The controls of the source rock lithology or climate were of secondary importance to tectonic effects, and such a retrograding fan delta are rarely reported and may be a stratigraphic response of connected rift basins at early stage of extension. Now, coming to the results of petrography, we find quartz arenite to subarcose sandstone. These are some of the pictures of the quartz arenites and subarcoses. Next, we show the rock fragments in the thin sections. The arrows mark the rock fragments. Then we have feldspars present in subarcose. These are the lithic fragments in the sandstone. Then there is the presence of bimodal grain size in the petrographic thin section photographs. These are the sparkling color muscovite lats, and then you have the sericite matrix. These are the heavy minerals, the zircons, rutile, tourmaline, and the different opaques. So now plotting our results, we find that the basin is predominated by quartz arenite to subarcose petrography, and that implies that the sediments are derived from craton interior. Now, plotting different types of triangles, we have the same results, that they come from a continental block provenance of cratonic interior. This is craton interior provenance, continental block provenance. And then here we find a predominance of non-undulatory quartz in the petrography, which indicates that the provenance is basically plutonic, which in this case is Singhbum granite. Now going to the geochemistry and CIA, when we plot the geochemistry, we see that both sandstone and shale are plotting close to the alumina and K2O line, and this indicates removal of the more labile CaO and Na2O. Now, from the geochemistry, we see that these are quartz-rich sediments, as is also evident from the presence of quartz adenites. It has to be quartz-rich. And from the geochemistry, we see that both shales and sandstones plot near the K2O of the triangle of CaO, Na2O, K2O, and that basically indicates they are from a passive margin. So the cratonic interior of a passive margin, that is the tectonic implication of the basin. So summarizing the inference from provenance history, the presence of pebbles of jasper, white chert, banded hematite jasper, volcanic and granitic rocks embedded in the sandy silty matrix indicates sediments have been derived both from iron ore group and the Singhbum granite. Evidence of dual provenance is also inferred from the sediment bimodality, textural and mineralogical maturity, and the presence of rounded and well-sorted grains. There is high value of quartz monocrystalline to quartz polycrystalline, and this indicates mature monocrystalline quartz grains have higher chance of survival in the sedimentary cycle than the less mature polycrystalline quartz and lithic grains. Now, the presence of well-rounded grains along with sub-rounded and well-sorted grains is indicative of sediment maturity and recyclicity. The paucity of feldspar, abundance of fine-grained lithic sedimentary, and evidence of sediment diagenesis are indicative of sediment recycling. Now, the ratio of stable, that is quartz chert particles, to unstable grains, that is feldspar and lithic fragments, indicates a compositional maturity of the sandstone. The presence of clay-rich matrix frequently replaced by silica and hematite, low content of feldspar, and the presence of chert, sandstone and granites as lithic fragments are indicative of dual source. Triangular plots are suggestive of sediment derivation from craton interior. Association of the recycled sandstone and non-undulous quartz are indicative of sediment derivation from craton interior. Now, what is the inference from shale geochemistry? The kolhan shales are dominated by illite, quartz, and fine crystalline dolomite. The average chemical index of alteration, that is the CIA value, is 71.8, and this is indicative of a granitoid source with a modest amount of chemical weathering. The high alumina silica K2O Na2O ratio reflects a derivation of sediments from stable cratons during tectonic quiescences. The sandstones with low chemical weathering, whereas shales are indicative of modest amount of chemical weathering. So the CIA values have some discrepancy which can be explained by transport segregation between the sands and the shales, and the alumina silica and K2O Na2O ratio do indicate that the clastics were deposited in a passive margin, cratonic margin, that is the tectonic implication. The petrographic features imply a source area dominated by granites and granitoids, tectonic quiescence, and many plant topography. Now, as the age of the kolhans, there is sparse geochronology data from various literature survey and field review. We come up with the age of 2.2 to 2.1 gigayon. So in conclusion, we say that the sedimentation pattern in the kolhans reflects a change from the braided fluvial ephemeral pattern to a fan delta lacustrine type. The sediment geometries and climates exerted a major control on the processes of sediment transfer. Repeated fault controlled uplift of the source followed by subsidence and forced regression generated multiple sediment cyclicity that led to the fluvial fan delta sedimentation pattern. So this is a 3D model where you can see the iron ore group on the left and the Singhbum granites to the right. And this is the thin presence of the sandstones, which is representing the fluvial fan delta system, and above it the thick presence of the shales, 200-meter thick, which represents the lacustrine system. And this is a modern picture of a fan delta. This is the lateral facies variation. So 2 more points in conclusion. That is, intermittent uplift of the fault blocks basically exposed the fresh bedrock to mechanical weathering, generated a large amount of detritus and resulted in forced closure of landlocked basin, repeatedly disrupting the fining upward pattern. Now the controls of the source rock lithology and climate were of secondary importance to tectonic effects, and such kind of a retrograding fan delta could be a stratigraphic response of connected rift basins at an early stage of extension. So these are the references, and I acknowledge my head of the department in Indian Institute of Technology, Kharagpur, and director of IIT Kharagpur for funding me to attend this conference, my supervisor, Professor Shubhashis Das, for guiding me all throughout the process. And I thanks Omics for giving me a chance to present the paper here. I also thank my parents, my sister, for their support. So, thank you.
Thank you very much. Thanks a lot, Ms. Kasturi, for your good presentation. And now we can open discussion. Dr. Ramasamy wants to ask a lot of questions.
All the people you are referring, right from the first speaker, the fan delta, when it is there, that is the starting point of the sedimentation. Fan delta will be the starting point of the sedimentation. And when the basin deepens, you are telling it is receding, it's a regression, it's a progradation, isn't it? It will prograde.
Actually,
no, one minute. When the basin subsides, the delta will prograde. Then when the fan delta progrades, it will fan out. Then underneath there are water, isn't it? So there could be some deltaic lobes. Some water body should be there. Paleo depressions might have been there. Have you noted any paleo depressions like that? Or otherwise the clay lenses must have been there. In a semi-crescent shaped clay lenses must be there, encircling your fan delta. That will support your fan delta. Encircling your fan delta, there must be a semicircular water body. A semicircular water body might have prevailed at the time of deposition, which should have become the site of sedimentation of the clay or shale or some other deeper environment. Number 2, this fan delta is found only in the south, isn't it? Only in the southern part of the eastern part, east and southern part of that, not in the northern part of it. Then the basin is deeper in the south, in the east, and shallower in the west. That means uplift has taken place where? The uplift, whether it's the tilt, it appears that it has tilted like this. The basin has tilted like this. This tilting has taken place when?
Actually,
it doesn't appear to be a constant sinking on both sides. It appeared to be a sort of a tilting along a one fault that was there on the western side.
So I'll come one by one. So for the sedimentation, I would like to explain it by a modern analogy. So today, if you consider Ganga, it is flowing from the Himalayas down to the Bay of Bengal. So it begins with an alluvial fan delta, and then there is the plains, and then there you have the fan delta at the mouth of Bay of Bengal. So basically, when you look at the sedimentary sequence in the lower kolhans, that is the Keonjhar basin, that is basically representing alluvial fan. And coming to the Chaibasa-Normandy basin, it is a fan delta system. And you have the preserved sedimentary channel that you're telling. Preserved sedimentary, I mean paleo channel is preserved. Which
No. The paleo lakes might have been there. Crescent-shaped paleo lakes encircling the delta, pro-delta region, there might have been a depression.
Okay, so such kind of depressions
You look for it, because this concept might not have. This is the present day what we are observing. Present day, what we are observing in quaternary deltas, present is the key to the past. So, you can see, you would have seen that one. Second thing is, it is a tilting. The tilting, influence of this tilting is not coming out in any of the presentations. Probably you may have to think, it is tilting.
I try to explain. Singhbhum, there is 3 phases of deformation, and the Singhbhum granite is basically rising. And you have this faulted contact, so one block is rising and one block is lowering. And there is Singhbhum deformation, 3 phase of deformation is there. So as the
you need not, you may think it, all the people who have come, you may think it, because that's one. And then finally, what this much of exhaustive study done by, it appears that all the 3 people are concentrating, putting more effort and brought out enormous data. Whether it has brought out anything new about the iron, manganese, ore deposits of that region.
Well, I will say that there is a huge limestone deposit in the kolhans, which are basically supplying limestone to the limestone industry. And then you have we are not concentrating on the iron ore group, but there is presence of the BIF and things like that, which are important for the iron ore industry. For our work, we have in this SEDI site, we have a lot of hematites, but then the industry has to come up with a method to extract that hematite from the SEDI site.
Okay, thank you, Kasturi. Who wants to ask Ms. Kasturi for, or who anyone to make comments for his nice presentation? Okay, thank you very much, Ms.